So the take-up tab is defaulted to auto mode, which means that the take-up tension and the weight have already been selected for you based on 6 different values. These values include the minimum take-up tension required to prevent sag during running, acceleration, and drift, as well as the tension required to prevent slip during running, acceleration, and drift. It then finds the highest number of those 6 values and adds 10%, which gives you the 3,740 pounds of tension. If I flip the take-up tab to User, it allows me to edit the tension or the weight. And let's say in our example, we have an even 4,000 pound force. So now that our take-up tension is set, let's take a look at the pulleys tab. In this example, we will only look at the basic design for the pulleys. When basic is selected, Belt Analyst will remove any calculations for shafts, deflection, and bearings. We can see the table showing the 3 pulleys that we have in our Flights tab. It shows the locations of each pulley, which is location 5, 6, and 11, as well as their T1 and T2 tensions. These values would be given to the manufacturer for their design process. If you are not in basic mode, you have many more design options, such as hub design, bearings, and shaft design. So now that our pulleys are finished, we will move on to vertical curves. You can see that the vertical curves tab is in auto. The auto mode selects a value that would prevent excessive liftoff if it's a concave curve, and looks at the high and low edge or center tensions for a convex curve. Belt Analyst will then select the highest value and then set that number as the radius of the curve. In our case, the radius to prevent liftoff in the first curve is 406 feet. This value represents the carry side of the conveyor. You will notice that matched up on the return side is flight 10. You can see below that it says also 2, which is also flight 2. This flight will have its own set of radius calculations. If the radius for its corresponding carry flight is greater than its own highest radius, it will take the higher value. This is the case because we have automatic return sections, which means the carry and return concave curves match up. If the Flights tab was in User Return mode, where the carry and return flights don't necessarily match up, each flight radius would be separate. For the convex curve, Belt Analyst will look at the tensions of the belt at the edge and at the center. It will calculate to either overstress or understress the belt, what the radius would need to be, and then print out the value. If we expand this folder, we can see that Belt Analyst also outputs a load per idler tension, which includes excessive loads due to the curve radius. It then suggests the idler spacing to prevent those excessive loads. So for our example, we will click User, and we will input a 450-foot curve radius, and we will stay with an 80-foot radius for the convex curve. So let's contract this folder and move on to the last tab, which is the Trajectory tab. This tab shows you where the material will travel as it leaves the conveyor, which you can use in a chute design. So now we have finished the input process for this conveyor. In order to complete the design process, you would need to put the conveyor through different cases in order to test the capacity of the components you selected. For example, dropping the temperature that the conveyor runs in, or changing the load conditions, as would be seen on site. As you go through each of your cases, look for components that turn red, which indicates an issue. That concludes this tutorial for the basic design of a conveyor. Thank you for watching, and if you have any questions, please contact Overland Conveyor.